Good afternoon, everyone on the East Coast, and good morning to you if you're on the West Coast. This is Sharon Hewson here at AEE, and I welcome you to our member webinar for Wednesday, June 5th. We have two presenters for you today. Joining us today, we have Dr. Kurt Roth from Fraunhofer, USA, and Mr. Owen Brady from National Grid. So I will go ahead and introduce you, give a little bio, and then I will go ahead and pass this over. So first of all, for Mr. Owen Brady, he is a product management specialist for National Grid's emerging products team, who work to bring together companies, customers, and communities to create shared value while solving complex energy challenges. Mr. Brady has always believed in the power of uniting stakeholders and around common goals, and is confident in doing so. That in doing so is the only way we will solve the energy dilemma facing our planet. In his time at National Grid, Owen has created the industry's first commercial gas demand response program, which was awarded the inaugural Utility Industrial Innovation in Gas Award by the National Association of Regulatory Utility Commissioners in 2017. He has also developed the non-pipeline alternative, the NPA framework, to support the utilization of new technologies, and was one of the leads for a recent rate case in which National Grid has proposed a number of new initiatives, including geothermal systems, power to gas, and hydrogen blending. Before moving to New York City and joining National Grid, Owen was the key accounts representative for Vermont Gas Systems in Burlington, Vermont, where he helped to establish the first natural gas, RNG tariff in the United States, and brought the first virtual pipeline company in the United States, NG Advantage, onto the gas system. Mr. Brady holds a Bachelor of Science degree in Mechanical Engineering from the University of Vermont and received his Project Management Professional Certification in 2014. He is currently enrolled in an executive MBA program run by Columbia University and the London Business School. In addition to Mr. Brady, we also have Dr. Kurt Roth presenting today. Now, Dr. Kurt Roth is he leads the Energy Systems Applied R&D at Fraunhofer USA. This team collaborates with industry on applied research to develop, analyze, test, demonstrate, and evaluate building technologies and technologies that enable integration of large quantities of renewable power with the electric grid. Currently, Dr. Roth is a co-PI for a DOE Sunshot demonstration project to optimize the operation of megawatt-scale PV energy storage and facility load management to enable the electric grid to reliably integrate high levels of PV, as well as a DOE Building America project to use communicating thermostat data to perform remote home performance assessments. Dr. Roth has also led several studies to assess the energy savings and commercialization potentials of building technologies, including HVAC, building controls and diagnostics, and information technologies, and analysis to characterize building energy consumption by building energy end uses. Excuse me. Dr. Roth has presented at numerous conferences and meetings and has authored more than 60 emerging technology articles for the ASHRAE Journal. Dr. Roth received his BS, MS, and PhD degrees from the Massachusetts Institute of Technology, MIT, all in mechanical engineering. He is a member of the American Society of Heating, Refrigeration, and Air Conditioning Engineers, that's ASHRAE, and the Northeast Sustainable Energy Association, NESEA. And on that note, I will go ahead and change presenters over to Mr. Brady, who will begin his presentation on gas demand response.
Thank you very much, Sharon. I am actually going to change the presenter over to Kurt. And that looks like Kurt has the presentation pulled up. Wonderful. Well, thank you all for taking some time out of your day, whether morning or afternoon, to join us. I'm very excited to be here with you and to be presenting alongside Dr. Roth to talk a little bit about gas demand response. And we have it titled here as the next frontier And I think truly it is an exciting innovation in a utility that, or a utility space that is looking to change itself, and I think needs to do so. And I think this represents a very interesting foray into customer enablement and the ways in which data can enable greater interactions with customers and a more efficient operation of the grid. So Kurt, if you could take us to the next slide, please. Just a question on my screen. It is kind of cut off. Is it cut off for everybody else as well?
Yes, it is on my screen.
See if we can just fix that momentarily.
Do you not see the second slide right now? Because that's what I have up on my computer. Let me try this again. So, does it show up now?
Perfect.
That's
exactly what we needed.
All right.
Excellent. And so I always think this is a good way to start a presentation, especially when thinking about a new technology or any sort of a change to an existing marketplace, which is really to say, why do this? And so we thought it would make sense to start off with the question of why gas demand response. And specifically, I can speak to the perspective from National Grid, which was why did we think that the opportunity was ripe to explore this, and what kind of led us down that path. So really, as I mentioned, there's always a desire within industry to optimize system efficiency and utilization. And this is something that we've seen become increasingly sort of recognized by regulators and community stakeholders, but it's always been an internal push to manage the system in the most efficient way possible, because as we'll talk about later on, when you're building for a very high peak, obviously that leads to some underutilized capacity, and so that's not ideal from anybody's perspective. So really looking at gas demand response, the primary driver was thinking about, are there ways that we could work collaboratively with customers to be able to improve that system utilization. So that was the sort of impetus for all of it. But more broadly, as we were thinking about this technology, we saw this being able to enable a number of new things. And thankfully, this work for us was started in New York State, and we have a very supportive regulatory body here, and they established something called the Reforming the Energy Vision Framework, which was originally designed for electric projects. And we said, well, some of the things that are involved in REV, reducing greenhouse gas emissions, empowering customers, these are all equally relevant on the gas side. So can we propose some gas projects as well? And one of them was a gas demand response pilot. And so we see understanding gas demand response and how we might be able to utilize it as a critical component of enabling things such as renewable gas facilities, anaerobic digesters, eventually power to gas, or even hydrogen, because if we're able to shape the demand curve to match the supply curve from these sorts of, if you will, distributed generation facilities, then it's going to be easier to bring them online without having to deal with a mismatch. So that seemed like a very exciting thing to us. And then really rewarding customer flexibility. We're seeing an incredible growth, I would say, in customer engagement in energy. I think pretty much everyone in the energy space has heard that metric that customers only think about their energy for about 10 minutes every year, but I think we are starting to see an evolution of that, whether that is due to simply changes to the customer's costs, or out of a desire to achieve different outcomes, or out of a thought that it's the prudent thing to do. It's wonderful to see customers that are looking at how they can support the energy system and be a much more active participant in it. So this was a chance to establish a program that would reward their flexibility. It's also possible that as we look at programs like this, that, as I said, rely upon data, that we might be able to provide that to customers. Again, if they're more engaged, they have more data, they'll be empowered to make the choices that are right for them. And so that's very exciting. And then kind of the corollary to the first point is this really may impact the need for additional infrastructure. And as we've seen in recent months and years, there is sort of an increasing challenge as far as installing additional gas infrastructure, especially at sort of the larger interstate level. And so trying to think about ways that we can be prepared regardless of decisions that are made outside of our control is something that seems prudent so that we can continue to provide good service for all of our customers. So that was kind of the grid perspective on that. Kurt, would you like to go to the next slide? And so this is a slide showing basically what I was talking about. If you have to build for that very high peak that you see on the right-hand side of the chart, and the rest of the day is quite a bit lower, then you end up with a massive amount of underutilized capacity, and that's not ideal. So the thought is, could you move some consumption outside of that yellow bar and into the rest of the day, effectively shaping the usage curve for these customers, not through a reduction of load, but simply through a shifting of load. And this is similar to the concept that's used in electric demand response, but it is a little bit different, and there are some distinctions that we'll be able to talk about a little bit later on. Kurt, before we go too far, do you want to give a little bit of context into what got Fraunhofer interested in participating in this space?
Sure, Owen. So I think a lot of it was, as Sharon mentioned at the beginning, we're an applied R&D organization. And so a lot of the work we do is to really help develop and test out novel concepts that can help lead to a more sustainable energy future. And so this, our motivation for participating in a pilot funded by the Massachusetts Department of Energy Resources in conjunction working with National Grid, with Owen and the team there, was to really see in practice, could this actually be realized in practice? Could significant amounts of load be shifted on these peak days away from the 6 to 9 o'clock window to other times, preferably earlier, as you can see from this plot? And then also assess whether reducing gas demand during this peak period, could that actually increase the pressures in the systems, in the places with the gas distribution system where there are constraints, to acceptable levels, which would obviate the need for system reinforcement projects, which can cost hundreds, if not thousands, if not millions of dollars in some cases, and also be quite disruptive in the communities. So that's really what our interest was, to really understand the answers to those kind of questions. And that's what we'll get into shortly, will be lessons learned from National Grid's pilot in New York, as well as the pilot that we've jointly done in the Commonwealth of Massachusetts.
Wonderful. Thank you for adding that in. I think it's important to highlight the fact that this was sort of an exploratory pilot. And the reason for that is that, as you heard in my bio, which sounded far more pompous when it was being read aloud than it did when I was writing it, this is really one of the first projects that's been done in industry, focusing on commercial customers and looking at sort of an incentivized demand response program on the gas side. And there's kind of been a feeling in the industry over the years that every 10 years or so, somebody brings up the concept of gas demand response, and it kind of gets a chuckle in the room, and then everybody goes on about their business. So it was exciting to have an opportunity to look into it, and it was very exciting to be able to partner with Kurt and the team at Fraunhofer so that we could think about what the potential for it might really be. And I think we've learned some important lessons in the 2 pilots that Kurt mentioned. I think there's still a lot to learn, but that's always the way it is with a new concept. So Kurt, if you can, let's go on to the next slide. And so really, most gas DR programs, including the downstate pilot and the pilot in Massachusetts, and forgive me if I say downstate, I'm referring to downstate New York, New York City, and Long Island, National Grid Service Territory in New York State, part of National Grid Service Territory in New York State. Both of those programs were really designed to look at distribution level impacts. So we were not trying to achieve a scale that was large enough to affect transmission or regional transmission lines. We were not trying to shift load outside of a gas day, so we were not trying to have events that would last for greater than 24 hours, and we were not intending this to be a supply or price-driven program. This was more looking at distribution system pressures. And so it's just important to put that out there, because demand response programs can be designed to achieve a lot of different outcomes. And so making it clear that that was our intent, I think, will color some of the comments that are made later on. Next slide, Kurt. There are two primary approaches to gas demand response that have been considered, and we have the two pilots that each featured different, one of the two. So the project in New York City and Long Island was a direct load control, or DLC, setup, which basically means that we installed a device at the customer site that would allow us to electrically disable a piece of equipment. So in this image you could see here on the left, if there were two pieces of equipment, the blue and the sort of light green, we would be able to disable one of those during the demand response event, and that piece of equipment would be inoperable. And so that meant that we could look at a capacity commitment based on the nameplate data of the equipment. The alternative would have been to do a fixed service level or a baseline approach, where the gas customer would manage their consumption in whatever way they saw fit, whether it was still shutting down that one piece of equipment or combining a number of changes and reductions to add up to the desired aggregate reduction. And that would be determined relative to a baseline that would be calculated based upon the previous usage data. And I think, again, it's important to talk about the distinctions between the two of those. Direct load control is much more similar to some of the non-firm rates that we have had in New York for a long time. So we have a rate that's called a temperature controlled rate, and many utilities have a peaking rate where there is a shutdown that occurs. And so facility managers and operators are often comfortable with that concept, but at the same time, as we'll talk about a little bit later on in the presentation, there are some concerns that come along with that. And it does require, as you can see here, some infrastructure as well. There needs to be device level control, there needs to be communications with the facility, and generally it needs to be a relatively live communication as well. So that's something that can come into play. On the other side, with the baselines, you know, it's more flexible for customers. Generally, they have a greater opportunity to be able to determine how to participate, but it does require their active participation. So as opposed to us flipping a switch and something changing at their site, they now need to make manual changes. And so that can be a little bit more interactive, but at the same time can allow them to have a greater level of flexibility. It does require the high resolution gas metering, which we tend not to have because we don't have a lot of AMI rolled out for our gas system. And so there is a need to either install that metering or make use of existing consumption data and interval data from a customer's site for building management system.
And one thing I guess I would just add is that we found that customers who have a bit more sophistication potentially in their facilities management team, that really helps if you're going to do a fixed service level kind of approach where you need to, as Owen was saying, bring together a variety of different potential control actions and decide what to do in near real time, or at least plan out in a lot of detail ahead of time of how to achieve these the target reductions.
That's a great point, Kurt. And one other thing is that because most facilities have gotten used to the cost of gas kind of being something that they just take as a sort of part of the business, a lot of the facility managers that we spoke to didn't have a clear sense of, if I turn the thermostat down by a degree, or if I lower the firing rate or something, that will cause X change in my consumption over a period of time. You know, it wasn't something that was deeply understood. And so when we were talking about the baselines, there was sort of a question of, we think this is what will make sense, but we have to sort of test that out. And I think that, again, speaks to kind of the nascent nature of gas demand response, where people haven't really explored that too much. And I think as we continue to see these programs get rolled out, I think it will be easier for customers to kind of understand how their facility responds and also understand what changes they can make to achieve the desired level of reduction. So the programs that we had structured were different in the type of control that they had, but they were relatively similar in terms of the DR events themselves. So as you can imagine, demand response is basically needed on the coldest days of the year. And for how many events are needed each year, it can be hugely weather dependent. There can be winters where you would never have a peak or a near peak day. And then there can be winters where you have 5 in a row or 10 across the course of several months or 20. I mean, it really can vary quite a bit, but typically it's fewer than 10. And so we structured these events to last for 3 hours from 6 a.m. to 9 a.m. And that was the same time window that was highlighted in that chart earlier, which you could see was representative of the most aggressive peak that is experienced by the gas system. The distinctions then from the New York program and the Massachusetts program, not a lot of changes here, slightly different incentive amounts and slightly different measurements in terms of how we got the data and what the granularity of the data was. But overall, the programs were fairly similar. And one of the most important things that we found with demand response was the need to make the program predictable. So I referenced our non-firm rates earlier, and a lot of customers can have the feeling that it's hard to be prepared for potentially longer duration curtailment events. And so the idea of having demand response where the events would always be the same time of day, they would always have the same notification period, that felt like something they could kind of wrap their heads around. And so when they were doing the sort of benefit cost analysis of the potential incentive that could be earned relative to the impact on their operations, on their staffing costs, it was a little bit easier for them to say, yeah, for 6 mornings out of the year, which was the maximum number of events that we could call during the pilot, that seems like something that we could manage. Kurt, anything to add there?
No, I think that's good. We can get into a few more details when we go through these specific case studies, I think. The pilots.
Excellent. On this slide, this was something that I put together because I thought it was so interesting to be able to see the different sort of fingerprints, if you will, for a variety of different customers. And so these are all commercial customers. They are all of roughly comparable size, and yet you can see that over the course of a week, which is the time scale that's presented here, their usage varies dramatically. And that comes probably as a surprise to none of us if we think about it. But I do believe that in considering whether or not the various initiatives would work for a customer, it can be structured in such a way that we try to make it very standard for all customers. And I think what this reveals is that there can be a lot of benefit afforded by really understanding a customer's usage and their profile for usage deeply and what sort of matters to them. The customer in the bottom left obviously starts up at sort of the same time every morning. If that's a critical thing for their operations, then obviously trying to get them to make a change at that time might be much more challenging, but perhaps they could ramp down earlier, later in the day, or make some other changes. So being able to have this sort of insight at a customer level is very interesting and frankly is somewhat new for the utility as well. We do have a lot of interval data that we get from very large customers, but there's sort of the next tranche of customers which are not very large but are still quite large, where we don't generally have interval metering there, and so we haven't been able to gain this sort of insight. And one of the structures that we put in place for the Downstate New York project was actually to make this data available to customers via the the customer portal that they could access. So they were able to see their real-time usage data, and it was at a level of granularity that they heretofore had not had access to. So that was very exciting to them, and some of them even expressed that was more exciting than the incentive payment because it allowed them to understand how their operations were running and what changes they might be able to make to make it more efficient. So currently, just to give a little bit of context here, that we have National Grid has 4 pilots running in 3 different states. So at the bottom of the screen on Long Island, you can see there's the red star representing our first demand response pilot. That was the one that was approved as part of the Reforming the Energy Vision framework. Then in the sort of Albany region, we have another demand response pilot, and that's focused on the Eastgate region of Albany, and that's going to be starting up this winter. Then in Rhode Island, we also are running a demand response pilot, which is part of our energy efficiency work. And that's interesting because we're going to be assessing the BCA for demand response relative to other efforts to reduce peak consumption. And so we're going to be able to kind of compare it relative to the avoided cost of service that we use for a variety of energy efficiency initiatives and to sort of understand what that might look like. And then finally, as we're talking about today, we have the pilot and the partnership with Fraunhofer in Massachusetts. So the findings from New York, recruitment proved to be a very interesting process in both states. And really, you know, we tried to take a sort of broad approach to marketing when we began. So we sent out mailers to roughly 650 large gas customers in our service territory. And we had a basically 0% response rate to that mailer. Not only maybe we sent out something that looked a little bit too much like a bill or like another flyer, and so therefore it went straight from the mailbox to the recycling bin, who knows, but it was a concept that customers didn't quite understand, and we're going to talk about that more. But it really required in-person visits by us and by our strategic sales group, people that had relationships with the customers and that could explain what this program entailed and help them to understand how it might work for them. Typically, these meetings would last for about an hour, I would say. And it would take the first 30 minutes or so just to explain what the concept was. And, you know, usually at the beginning, it was sort of hands up, no, there's no way we'd ever be able to do this or that we'd ever be interested. And then as we started to understand it's a very fixed time window, here are the sort of various aspects of the program, eventually they started to think about ways they could participate. And typically by the end, they would say, oh yeah, we have this piece of equipment over here, but we also have another one in another part of the building that might be a great fit as well. So it was exciting to see that sort of dialogue happening. And I think it was refreshing for the customers as well to have that sort of a collaborative opportunity to come in and chat with the utility, because I think there can sometimes be a little bit of a transactive relationship. And so I think this was a nice chance to have a little bit more of a free-flowing dialogue. As mentioned here, we had 16 participants in the first year of the pilot. Between year 1 and year 2, one participant dropped out due to operational changes at their facility, but another participant was added. So we maintained that level between the 2 years. And in fact, the participant that was added was significantly larger than the one that dropped out. So we actually increased our reduction between the 2 seasons.
So I'll talk a little bit about the recruiting for the Massachusetts pilot. We reached out to 60 very large gas customers in National Grid's gas service territory in the Commonwealth through contacts that National Grid already had. And this was email and phone-based contact. And we got roughly about a third of those customers who we heard back from. And then overall, we were able to have follow-up calls to really understand this better to present it to them in more detail and for them to understand it better with about 10 of those 60. And it was interesting understanding what they're interested. They were intrigued, I think, by the opportunity to potentially access a new revenue stream. That was appealing to them. And also we found that several customers were interested in access to real-time gas data. As Owen was mentioning, part of this was to really provide people with much more insight into their gas consumption, to get hourly profiles and much more granular data, sometimes down to 1 to 5 minute kind of time resolution. And people really expressed a strong interest in having real-time access to that kind of data, because they in most cases did not. We had follow-up on-site meetings with about 10% of the customers, and ultimately of those, we were able to recruit one large customer, the University of Massachusetts at Lowell, and who turned out to be a great partner for the pilot. Just to be clear, this pilot had a significantly smaller scope than the New York pilot by design, but a bit more research kind of aspects to it as well. And I think we'll get one thing we were able to do to really understand customers' perspective better was to do a gas demand response survey, and we'll show some of those results in a couple minutes. But I think, you know, one thing that really came out of the discussions with customers in Massachusetts was concerns about direct load control. They're very concerned about losing control over their systems. This was across the board, C and I, but even more so the industrial customers were very concerned about the possibility that there might be an outside entity controlling their devices. So that led to this change in our pilot design to go to a fixed service level kind of approach in the Massachusetts demonstration project. And so overall, some of the key takeaways, we've touched on these already to some extent, but I think a key thing was customers just were not familiar with the concept of gas demand response. Some thought they'd been offered that. They said, oh, we've been offered this before. And we're pretty certain they hadn't. It could have been electric demand response possibly, or maybe a third-party energy supplier trying to craft some kind of deal with them. But it was something that they had to be walked through the concept and had to really kind of get their heads around it, because it was something very, very new for them. We also found that as Owen did in New York, the same thing in Massachusetts, that commercial and institutional customers were most likely to participate. Industrial customers were just so reluctant to interrupt their major process loads, things at the core of their business, and that potential disruption. They're even concerned about potentially what if there inadvertently was a shutdown by some kind of bug that would have shut down their loads, their processes. That would really be a real problem for them. So really the industrial customers, although they had a lot of gas consumption, ended up not being major participants in the pilots. Also, as Owen was touching on, the gas metering infrastructure with the temporal resolution required for doing gas demand response and quantifying what's going on, that was not there. And so nor was there the infrastructure in place for direct load control. So that was something where additional kinds of controls had to be installed on different types of equipment to be able to control that. And also the metering infrastructure had to be installed. And there was a process in terms of working out some of the kinks with those systems that Owen could potentially talk about a bit more, but that was something that was helpful to work through that. And then we, in the Massachusetts case, didn't have problems with that. And I guess also mentioned the problems with direct load control. And finally, one thing we did find was people who had participated in electric demand response programs and had not had a positive experience. For example, they might have thought their baseline wasn't representative, and so they didn't get the kind of performance and the kind of payment that they thought they would get from electric demand response, despite taking what they thought were actions that should get them that kind of performance and therefore kind of remuneration. People who had bad experiences with electric demand response were very reluctant to dip their toes in the water for gas demand response, which they understood much more poorly. But I think a key takeaway was if there was an internal champion who was able to see the potential value here and to really give go ahead and give this thing a try. That's when, just like so many different things around energy efficiency and electric demand response, that's when things really moved ahead. Oh, and I guess, would you like to add anything here before we get into the survey results?
Yeah, there are two things I'd like to add, and they actually will also speak to the questions that have come in, and I think they help to understand where we started and kind of where we ended with this. So the point about industrial customers, our first hypothesis, if you will, was that process-driven customers, so industrial customers, would be able and willing to shift the time of their production in response to a price signal. So if they made a batch of widgets at 6 a.m., they could probably make a batch of widgets at 9 a.m. and there would be some cost that would be acceptable to them to make that change. And we understood that would likely come along with, as I said before, sort of staffing changes or things like that, but we felt that it would be an economic equation for them. And what we found when we talked to them was really that there was basically no amount of money that they were realistically going to consider, or certainly nothing that was within the scope of the budgets that we had, to get them to make those changes and to have that sort of unpredictability in their process. They had, raw materials that came in at a certain time, and they had shipments that needed to go out at a certain time. And so having somebody else, whether it was through direct load control, controlling the equipment, or simply impacting the sort of state of their business, that seemed like something they wouldn't consider. But they generally said, but I'm happy to turn down the temperature in my facility and say to my staff that you might want to wear a sweater this morning. So that really led us from thinking about process loads to thinking about heat loads. And of course, on the electric side, space cooling and conditioning is one of the primary drivers of electric demand response. But we had sort of thought that heating was unlikely to be similar, even though that would be the logical analog. It wasn't something we thought that customers would consider. So we were very surprised by this, but it's exciting because it allows sort of penetration into a part of the market that we hadn't looked at. And frankly, in a very sort of heating dominated climate like we are here in the Northeast, it's going to be helpful if that's something that we can leverage, because that's going to be perfectly coincident with our highest usage peak. So we found that customers were willing to look at heating. Many of them were willing to look at preheating, very similar to the pre-cooling. So, Mr. Chen, this is, I believe, to your question. And so they were able to preheat the facility and then coast by either with basically no heating input over the 3 hours, or with limited heating input based upon what they had committed to the program. And so it was very exciting. And in fact, some of the facilities, would commit maybe, let's say, one of their 2 boilers, for instance, but they actually would, during the event, shut down both of them because they were curious how the building would respond and how quickly it would lose heat under these kind of adverse conditions. So it was very interesting to see the customers sort of exploring this and understanding how they could use energy and what would work well for them. So that, again, shifted our focus into primarily heating loads, and I would say that has been the majority of the demand reduction that we've been able to achieve, certainly in the downstate New York pilot, but I would say also in the Mass pilot as well. And then just speaking quickly about the metering. So one of the other things that we wanted to do with this pilot, since it was designed to be somewhat quick in its time scale and also sort of fixed in its length of life, was we wanted to make the metering as non-invasive as possible. So we identified a solution that allowed us to leverage the existing gas infrastructure. So we basically had a KYZ pulse output device installed on the gas meter, and that stream of pulses was collected by a box that was on site, the ICE box that was furnished by IP Keys, which was the vendor for this pilot. And that allowed us to get that stream of data and to communicate it out from the site. That communication was achieved in 99% of cases via cellular. We did have one site where, despite adding multiple antennas and boosters and trying to move the box around, we just could never get a stable cell signal. And so we ended up using a LAN connection there, an Ethernet connection because that seemed to be more reliable and what was necessary for that site. But again, it highlights the fact that if this data resolution is available, if the AMI metering infrastructure, for instance, is already in place, then it makes it far easier to look at these programs, and certainly, as we'll talk about in a minute here, more easier to look at those sort of baseline programs as well. Typical costs to enable the site would vary depending upon the necessary modifications to the gas infrastructure. So if we had to change out the meter or things like that, that could impact the cost, as could whether or not there needed to be multiple ice boxes at the site. In some cases, we had one box that was just for collection of data and another that was for control at a different part of the facility. But typically, I would say sort of, $3,000 to $5,000 was kind of what we were looking at from a budget perspective for enabling these sites. Plus, there's ongoing communication costs as well. And then the one other question that came in just while I have the microphone is, have you seen GasDR used on code generation systems? And for this pilot, we had, for the downstate New York pilot, we had not allowed code generation systems to participate. But the main motivation for that was simply that it seemed like pitching the concept of GasDR was going to be complicated enough without getting into what would the impact on electric costs be, would it impact electric peak demand charges. There can be some other interdependencies that happen with cogen systems. That does not mean that we would not consider it in future programs. It just wasn't something that was a part of this one.
All right, we have a little under 20 minutes left now, so we're going to move ahead and get into the results in just a minute. And just to quickly summarize the gas demand response survey, this is something that we work with National Grid. Fraunhofer developed this, and we feel with input from National Grid, and we fielded with National Grid customers in Massachusetts. And what we found, these are commercial industrial customers, and what we found out was, the ability to opt out of events was really, really key for a lot of people. Just depending upon their specific circumstances on a certain day, they wanted the flexibility to, if they really felt they couldn't participate, to do that. And when we did kind of a fixed choice option in terms of questions, they indicated they were willing, in most cases, in vast majority of cases, to accept a lower compensation level if they could maintain control. And as Owen was talking about, real concerned about disrupting operations, and this had a significant impact both at the commercial and industrial level. For example, UMass Lowell, when they were participating in this, they indicated that they had to have classrooms ready to go at 9 o'clock in the morning. They couldn't compromise the comfort. So that's something where it was very important to understand to maintain a good level of service so that it wasn't affecting the core mission. We talked about the implementation challenges, and this was really a challenge, not just in terms of the technical implementations, but people understanding how they could actually achieve different demand response strategies, how much reduction they could get, how long should you preheat, how long could you ride through, how much should you heat during events while you're to some extent riding through. So those are all questions where they just haven't faced this kind of challenge before, and they had to figure it out. So this is an area where technical support in the future could be very helpful. And in some cases, we asked if fuel switching could be a possibility, and the answer is potentially yes, but it takes time and it takes resources to do that. So that's something which in a lot of cases was also a barrier to that kind of approach. We did also ask about time varying rates. So you can imagine time of use kind of rates where you might have higher rates during 6 to 9 a.m. And that's something where I think, again, this is a new concept. People would have had to figure out, how would we adapt to having, say, on a critical peak pricing kind of day, much higher gas rates during certain hours. That's something that they just hadn't really been able to think through. And finally, in terms of wanting notification, typically 2 days ahead was what was done. They could usually work with that. Most people could. Some people wanted 3 days, but 2 days was typically sufficient. So now to get into the results, Owen, do you want to present what you found in New York?
Yeah, and I'll try to also move quickly so that we do have some time for questions. This is a representative usage trend for our customer. It's sawtooth because of the way the data was collected. We effectively reset the counter in each minute. So if it looks a little odd, that's why. But the sort of the tightness of the grouping represents greater consumption, and so obviously the highlighted yellow area where there's very little consumption is the event window, and so you can see this customer effectively mitigated all of their gas consumption during that period, other than a couple of spikes which tended to relate to the pilot light or a very small amount of kind of idle usage for the equipment. And that, of course, is something that was allowable and expected because we were doing an electric interrupt rather than a gas interrupt, but it also simplified the operation for the customer. So very positive results. You can see that in terms of nameplate gas consumption, we had significant reductions, and that was exciting to see, but at the same time said, well, maybe that's a metric that we should think about in the future, whether that's the one we want to continue to utilize. And so that's why the sort of baseline based results coming out of Massachusetts are also very exciting in terms of informing our thinking for the future. So Kurt, if you go to the next slide, the chart that you'll see, Kurt, could I get the next slide?
Yeah. Oh, geez. Sorry, something happened there. You got it?
There we go. Yeah, I got it. Yep. So this chart shows the delta pressure, the delta PSIG normalized to 0 at midnight for a fixed pressure governor on our system. And this was picked in an area that had a smaller amount of kind of aggregate flow for the surroundings, which hopefully would highlight any changes. And so this was, one day that we picked out, and you can see that I have some comparables there as well in terms of similar heating degree days. I didn't do an effective degree day comparison, but just tried to look at the heating degree days. And you can see that the blue line, which represents the demand response event day, is flatter than the others. And so there is less pressure drop overnight. There is less pressure recovery during sort of the midday, which would make sense if the customer was kind of coming back online. And then there's sort of a similar trend in the later part of the day as well. And there were other days where this was not quite as clear, which is why, again, I think this is sort of an exploratory phase for gas demand response. But I think this speaks to what we hope the potential could be, which is, again, that sort of shaping of the load curve. And you could imagine that if this was extrapolated over many customers, it could have a potentially positive impact on overall system pressure.
Great. And so in Massachusetts, as we mentioned, we used a baseline calculation approach instead of doing direct load control, because the university we worked with indicated that they felt that they wanted to remain in control. They would figure out the strategies that would minimize the impact of curtailing gas consumption on their campus, and wanted to go ahead and do that. And what we ended up doing was hourly regressions between the hours of 6 and 9 o'clock in the morning on non-event, non-vacation weekdays before the gas demand response program started, where we essentially did a heating degree hour relative to a base temperature of 65 degrees Fahrenheit. So if it were 0 degrees outside, for example, then it would be, the heating degree hour would be equal 65 for that hour. And you can see we get, very nice linear fits, R squared of around 0.9 or greater, so very good, high goodness of fit for this kind of baseline approach. And we got that for all the 4 facilities. They had 2 heat plants and 2 buildings participating in this study. And so for all those buildings, those facilities, we had similar kinds of regressions where you had a very high quality fit. And so that's how we calculated the baseline. And the next slide will show the actual results. So this is during the event window. You can see here on the right-hand side. This is from 7 o'clock, essentially, just to be clear. This is it should have been actually between 6 and events. Part of the window is cut off there. But essentially what happened is you can see during those 3 points, which are in the yellow portion, that's when the event was going on, and there was almost a 40% reduction in gas consumption during that event window relative to the baseline, which is the dotted line. And so this is great. They had great performance and across 4 different events that were called. And they used a variety of strategies to achieve that. One was preheating spaces. So instead of starting to warm up buildings, say maybe at 5 o'clock in the morning or something like that, they would start a couple hours earlier. And then what would happen during the event, the temperature set points for the spaces would be decreased, as well as for the heat plants, the temperature of the hot water delivered to buildings was decreased appreciably as well. So what this really allowed you to do was to decrease the loads significantly that had to be met, and therefore decrease gas consumption significantly. Also, in some cases, the outdoor air provision was curtailed to spaces that weren't occupied. So this is a way to further reduce the load in certain buildings. So this was something which is really exciting to see this kind of performance. They had a system that was providing 15-minute data already in place for gas consumption, and so made it really easy to benchmark this kind of performance. And again, this is performance over 4 different events, and this is pretty typical of the results that were achieved. And this is broadly consistent with Owen, where you're seeing something on the order of around 50% reduction. So, very, very consistent with that. One other thing we did in our part of the study was to really take really get an idea of what how gas demand response could potentially address constraints in the system. Because typically now, if the pressure drops too low on peak days, it indicates there's a need for system reinforcement, where you have to go in and put in, say, a larger pipe, which has significant cost and also is disruptive, as you have to dig up the ground or the street to put in a significantly larger pipe to really serve the area where they have the lower pressures. And so we did a really interesting study with National Grid's infrastructure team, where we looked at system reinforcement projects they've done in the past in Massachusetts, where they've gone in and put in, say, a larger pipeline, larger pipe in the ground. And then what we looked at was, at different levels of gas demand response, what they modeled using the whole system model, at different levels of gas demand response, what kind of reduction what kind of increase in system pressure did that have, and how that compare to the system hardening kind of projects. So if you look at this slide, this really shows the results of this assessment, and it's very interesting. So they looked at 5 different projects here, and you can see the different levels of reduction in gas demand, 0 to 30% on the top axis, and then for each project, the normalized pressure with different levels of reduction relative to the pressure that was achieved after doing the system reinforcement project. And you can see in the first one, for example, around 20-25% reduction in peak gas demand resulted in the same level of reinforcement, the same level of pressure as the gas reinforcement project. So the gas demand response in this case could potentially eliminate or postpone the need for system reinforcement. Whereas in the second project, you can see the highest ratio is 0.85. So gas demand response wouldn't have been in that case sufficient to do it. The one which is really intriguing is project number 4, where essentially there's around a 25-30% reduction in gas consumption during the peak periods. You'd achieve the same levels of system reinforcement, and if paying the levels of incentives that we did in our pilot, you could pay for a gas demand response program for over 30 years to get the same level of effect as you would from system reinforcement. So this really suggests that in certain specific cases, again, this is just looking at 5 projects, you want to look at a much larger range of projects. It does indicate that gas demand response has the potential to really potentially be a cost-effective way to postpone major system reinforcement projects. So again, these are modeled results, and it's only a few cases, but it does show some promise. I don't know if you want to touch on anything here, Owen?
No, I think you covered it well.
Okay, great. So now we'll just move to the conclusions of our overall project. I think what we did show from preliminary test results do show that facilities can, well, definitely the field testing shows that facilities can achieve their gas reduction. And then the system modeling shows that gas demand response can potentially defer system reinforcement investments, and sometimes it does appear that that could be quite cost effective. Recruitment remained was a significant challenge across the different pilots. It's something where people are not familiar with this. They didn't know what to make of it. They need a lot of support in terms of how to do it and how to implement it. In some cases, that'd be potentially very helpful to help them achieve it. And we did see a preference for something where they retain control, a fixed service level where they would get paid relative to a specific baseline. And it seems like a really promising way to move ahead with this is to leverage existing energy efficiency programs. A lot of these major gas users have very close relationships with the strong energy efficiency programs in Massachusetts, New York, and other states. And those strong customer relationships, account manager relationships, can be potentially very helpful to have the trust to really, and also to help get people interested that it can be possible and it won't be incredibly disruptive, and also the technical support to really help make it viable. And as Owen noted, there are a couple more national grid pilots ongoing in New York and Rhode Island. And yeah, I don't know if you want to touch on the expanded DR proposal in the rate case, or Owen?
Mostly I was leaving it in here, being mindful of time, just to say this is something we're still continuing to explore very actively, and something that we do think holds promise. I think there is still, as I said, more to learn about the best way to structure these programs to drive adoption and how they can best be complementary to other initiatives, but it's something that we are continuing to look at.
Great, and I guess now after going through these projects, I think this is really enjoyable working together on this. But we do, I think, there's still some outstanding questions. We did look at, there was some great work done by National Grid to model the Eastern Massachusetts gas system in terms of to evaluate what reinforcement projects could be potentially supplanted by gas demand response. But this is something where we only looked at 5 sites. We want to look at a larger site to see how universal, what portion of projects could realistically potentially be displaced. And of course, things have to be reliable, because if you're going to not do a project and the pressure is going low, you need to make sure you get the response. So understanding how realistic that is, if there's a specific customer, or you could rely on more of a portfolio in different cases, that's important to understand. Also, participation level as a function of incentives, that's something where there's some nice data from New York to get a feel for that, but want to see that across a larger range of population as well. And also the gas demand response potentials. As Owen showed earlier, the profiles in terms of how people consume gas varies extensively among different customers, depending upon how they operate their facilities, what their working hours are, things like that. And understanding that range of potentials, just like for electric demand response, this is not at all equal among facilities and different end uses, and that needs to be understood. Similarly, participation, how does that vary by customer type? We found that institutional customers were particularly willing. They might have a more sophisticated operations staff, but is there, we did have some, the New York pilot did have some commercial customers that participated. What are ways to potentially have industrial customers participate, or is that really not the most viable customer type to approach? So understanding that better. And then finally, you start thinking about things like, this is one approach. What if there were time of use pricing for natural gas on critical peak days? Critical peak pricing has done a lot of things in the electric world. Maybe it could be helpful in gas. That's something, as another parallel avenue to potentially explore. And then in terms of baseline approaches, we looked at cooling degree hour approach worked great, because the loads were really driven by the outdoor temperature. But is this something that makes sense for other customers where they might have somewhat different mix of gas loads, particularly industrial customers? And how do these baseline approaches affect outcomes? Because that's something which has been shown, and customers expressed a lot of concern about that in the electric DR world. So these are some great questions which I think are still out there, but made a lot of progress towards answering it through these pilots. And finally, I think we'd like to really acknowledge some people. Michael Zeifman at Fraunhofer is the principal investigator of the Massachusetts Department of Energy Resources project. So his work is underlying all the Massachusetts work. He did excellent work on this project. Stephen Caleri at National Grid did the gas system modeling, which really enabled us to get some innovative results in terms of what gas demand response could really do in terms of supplanting system reinforcements. And finally, we'd like to thank the Massachusetts Department of Energy Resources for funding the Massachusetts pilot. Owen, I guess, are there any last words you'd like to add?
No, I think unfortunately we are at time. There was one other question that came in asking about the interaction with non-firm rates, and I will say I'm happy, as I think Kurt is as well, to continue the conversation. So on the next slide, I believe, is our contact information. And so if you have any questions, if there's anything you'd like to discuss further, we're happy to have those conversations. So please don't hesitate to reach out, and then we can certainly talk further. So with that, I think we are at time, and we want to be respectful of that. So thank you all for taking some of your day to listen into the conversation, and we look forward to continuing this work and to hopefully hear from some of you about your gas demand response efforts and how we might be able to help accelerate the evolution of this offering so that we can see it adopted in more gas utility markets across the country.
Well, thank you both. Thank you very much to Dr. Kurt Roth and Mr. Owen Brady for your time and expertise today. Thank you to all the members who have joined us today. Just a couple of things just quickly. We do have another member webinar coming up on Tuesday, June 11th, next week. That will be presented by Mike Easton of QMC. And the title of this one is IoT and metering, making metering easy using wireless communications. So I'm sure many of you have already registered for that, but if you haven't, please go ahead and join us for that if that's of interest to you. Also, I will be sending out an email through GoToWebinar to each of you that attended today. You should receive that either tomorrow or Friday. That will contain a link to your certificate of attendance for today's webinar, and also a link to the recording of today's webinar. Thank you once again to everyone who attended today, but a special thank you to Dr. Kurt Roth and Mr. Owen Brady. On behalf of AEE and all of the AEE members that tuned in today, thank you so much. We truly, truly appreciate your time today.